Hey everyone, it's Bradley Bush with another algebra video for you. Today we're talking about systems of linear equations in two variables. Because we're in two variables, meaning we have two variables in our equations, we're in two space, or we'll be drawing lines on the xy coordinate system. So there's a little reminder for you. Our to-do list, first off, we'll have a review of systems of linear equations in two variables so you kind of understand where we're coming from. And second, our case study today, or the focus of this video, is the no solution scenario. So there are three solution scenarios in these types of problems. You have no solution, one solution, or infinite solutions. And here we talk about the no solution scenario. I have a detailed explanation of all the parts of the video in the video description with timestamps. So if you want to skip ahead to a certain spot, please do. Let's start. So what exactly is a system of linear equations in two variables? It sounds kind of terrible, but it really isn't. Two variables simply means we have two variables in our equations, like an x and a y. That's not bad, right? They're linear, so that means we're talking about two lines if we have two equations. And we know they're linear because the exponents on the variables are 1. And when they're 1, they're implied and you don't see them. So it looks like there isn't an exponent. So the good thing to know is you'll never have an exponent of anything crazy. You shouldn't see exponents at all, actually, because they're 1 and implied and not there. So we have lines. We have two lines. That's it. The last thing is, what does a system mean? Well, it just means you have more than one line. So here we will be dealing with systems that have two equations. So we have two lines, and we really just care about where they cross, if they do cross at all. So it sounds complicated, but it's really not. Here's an example of a system. Here's an equation 1, here's an equation 2. All of my equations are labeled with a number and a circle around it, so you know that it's a label and not actually a number. So you have two variables you can see, two equations, two variables, not too bad. What is a solution to this type of a system? If they say solve the system, what do they want you to do? They really want you to find the place that these 2 points, or the point where these two lines cross, if they cross at all. And so that point will be an xy coordinate. And again, we have three possible solution options. You cross once, you don't cross because they're parallel, the two lines are parallel, or you cross everywhere, so you've got infinite solutions. If they cross everywhere, that means the two lines are kind of right on top of each other. They're actually the same line, and so every point on one line is also a point on the other. How do you know what option you're in when you are given a system? Well, good thing for us, it's fairly simple. You just start solving the problem. And if you get an answer, you're in option number 1, meaning you have one solution and that's it. That is, as long as you did your algebra correctly. Otherwise, when you're solving the system, all of the variables will drop out, and you'll just be left with numbers and equal signs. If those numbers and equal signs make a true statement, like 0 equals 0 or 2 equals 2, then you are in option number 3, and you have infinite solutions. If those numbers and equal sign make a false statement, like 0 equals 2 is not a valid mathematical statement, then you have no solution, and you're in option number 2. How do we solve these types of systems? Well, we have two methods generally. We have addition and we have substitution. In this video, we will be discussing the addition method. So let's get to the case study. No solution scenario. So that's what we're expecting. We've got two equations here. Here's our system, and we want to solve this system, meaning find out where they cross, if these two lines cross at all. So the idea is, using the addition method, is that we want to cancel some variables, one variable. So if we look at this, if we multiplied the first equation by 2, they would have 10x here, and when we added the two equations, the 10x, the negative 10x would drop out. So let's do that. Let's multiply equation 1 by 2. So I pop down equation 1 here, and I'm multiplying it by 2. Equation 2 we don't change, so I've just carried it down. So what is 2 times all of this stuff? So let's distribute the 2 through. We multiply everything in the equation by 2, and what do we actually get? Well, 2 times 5x gives us 10x. 2 times negative 2y gives us negative 4y. 2 times 4 gives us 8. Now we add these two equations. We're going to label. So we labeled equation 2 because it is still equation 2, but we labeled this other equation here 1.1 because it came from equation 1, but it wasn't the same as equation 1. It's the newest iteration of equation 1, so we called it 1.1. Now we just add these two equations, and what do we get? Well, we see these cancel, right? That's nice. Oh, those actually cancel too. And what happens here? And we have 15. Well, that's a little awkward, right? Does 0 equal 15? Nope, it actually does not. So because 0 equals 15 is not a true statement, we know we're in the category where we do not have any solutions because these two lines are parallel. So the solution then would be the empty set. That's what this little 0 with the slash in it means. And the curly brackets mean that this is the set that contains all the possible answers, and there's nothing in there. There's no solution. And if we look at the graph, we can see equation 2 here, the purple. We can see equation 1 here in the green, and they're parallel. They never touch. So we do not have a solution for this system of equations, meaning they never touch. Hopefully this helped you out. This was using the addition method to solve a system of equations, which didn't turn out very good for us because there wasn't a solution, but that was the whole point of the video. We used the addition method to try to solve a system of linear equations in 2 variables. If this was helpful, please subscribe to the channel, and thanks for watching. Have a great day.